Hey, Dr. Clark here, and in this preview video, we're going to be looking at Section 8.2, solving homogeneous linear systems of differential equations. Let's take a look. So we're going to focus mainly on the 2x2 systems here, that is x and y. Everything we're going to do here in theory can be done with more variables, but it's simplest in the 2x2 case, and so that's what we're going to focus on. And the way this is going to happen is we need to notice something about vector fields, in particular the geometry of a vector field, and we'll explain what a vector field is in a minute. We're going to learn just enough linear algebra to explain that, and then we're going to apply that linear algebra skills to solving the actual differential equations. So that's going to be kind of the 1, 2, 3. So let's take a look at first. Bursting through. So how we solve this system of linear differential equations, eigenvectors. We'll see that in a minute. Okay, so first off, we need to talk about vectors. So we can write vectors using this bracket notation or a column notation. We've been talking about vectors already. What we're going to really do is think about vectors in just R2 because it's a x and y 2x2. So a vector is really just a column of two numbers organized like that. But the thing that we need to do is not just have a single vector like the vector 1, 2 or something. But we need to go to every point in the plane and put a vector at that point. So if you're at the point 3, 7, you got to draw a vector of a certain size there. And if you're at the point 4, 8, you got to draw a different vector. So in some sense, what we really have is a function. So a vector field is really a function that takes in a point, x, y, and on that point graphs a vector. Okay? And this is best done visually. So here's one. This is a vector field. So here's the point 0, 1, and there's the vector 1, 0 drawn at that point. Here's the point 0, 2, and at that point there's another vector. Up here there's a vector, right? Every point gets a vector. You get a vector, you get a vector, everyone gets a vector. It's kind of hard to see this when you try to graph it, though, because there's so many vectors, and I haven't even drawn all of them. I just drawn some of the vectors, right? It would be covered in red if we tried to do it. But there is something called a direction field where you shrink all the vectors down so that you can kind of see what's going on. And you'll notice at different points the vectors look different. So here the vectors are kind of pointing to the right, but here they're kind of pointing down. Here they're pointing straight down. There they're pointing to the left. Right, so at each point you can sort of get a different shape of the vector. Now this is called a direction field because we shrunk them all down. A proper vector field would have different length of vectors at each point. Okay, and so when we say a vector field, what we really mean is a function that takes in a point x, y and spits out a vector at that point, and the best way to see it is to graph it. Okay, now what does that have to do with differential equations? These are just graphs of vectors. Well, if you have a system of differential equations like x prime equals x plus 2y, y prime equals x minus 3y, something like that, a linear system of two differential equations in x and y, we can convert that to the matrix vector problem. We did that last time, right? But you can also think of this over here as a vector function, right? It takes in a point x, y, and it spits out a vector x plus 2y, x minus 3y. Okay, so there's sort of different ways that this thing can be thought of, and one of them is to think of the right-hand side as a vector field. Okay, and derivatives are telling you direction. Where is this thing going? Its velocity. And so in some sense, a direction field would say, if you're here, go this way. And if you're here, go this way. So doesn't that actually feel like derivatives, right? Derivatives tell you where you're going. If you're right here, you're going this way. Now, in a direction field, you only learn the direction. In a vector field, you would learn that at this point, you're going this way really fast, and at this point, you're going that way a lot slower, right? So, but in some sense, the differential equation says, how is x moving? Well, its derivative is x plus 2y. So you can put that in a vector, and you can put the y derivative in a vector, and then you've got the direction at the point xy where the solution would be going. Okay? And for this problem, if I graph that, I would get this vector field. Well, actually, this is a direction field, so I made it a direction field so we could see it. But properly, there would be a vector field here. And the key understanding is that a differential equation system can become a matrix problem, but you can also think of the right-hand side as a vector field. And when you graph the vector field, there's going to be properties. And look at it right here. Do you see how like some of these vectors are kind of curving, almost like there's like water is flowing in a curve? But right around here, there's kind of like a line that's building up. Like they're coming up here, but going down there. And so there's going to be kind of a line right there. And kind of in this direction, they're all kind of flowing in a straight line as well. And so there's going to be what we call straight lines in the vector field where the vectors go along a straight line. There's one and there's one, okay? Over here, it doesn't go along a straight line. It kind of like comes and then curves, right? So there's not like straight lines going this way, but there is a straight line there and there is kind of a straight line there. And that's going to be the key. If we can figure out, given a vector field, or better yet, given a system of differential equations, turn it into a vector field, graph the vector field, and figure out where are the straight lines, that's going to be how we find a solution. So it's all about finding these straight lines. And in class, when we get there, what I'm going to show you how to do is find the straight lines. And it's all going to come out of this vector field. The straight lines will get graphed for us, and that will tell us what the solutions are. So the solutions to the original differential equation system are going to come from finding straight lines in a vector field. And that's the main idea. Okay, so in class, I'm going to show you the details, but hopefully you get the idea that there's going to be vectors, there's going to be these differential equation systems, they turn into a vector field. Something about straight lines in the vector field helps us find the solutions back to the original. So we're doing just enough linear algebra to find those straight lines, and then back to the differential equations to actually write down the solutions. So we'll see you in class, and we'll learn about it then.